So on today's notes, we're going to be comparing decimals and fractions. Now, on a previous video, we already talked about inequalities and how they're always hungry. They want to eat the bigger value. We should know that this means less than. We should know that this means greater than. Okay, so when you're comparing two numbers like 4 and 5, we all know that 5 is greater than 4. So we know that it has to open up to the 5, right? Because it's hungry, right? It wants to eat the bigger value all the time. So let's start comparing decimals and fractions. In order to compare decimals, it'd be a good idea to review again the position of the digits on the right side of the decimal. So this first number is the tenths position. The next one is the hundredths. The next one's the thousandths. And when we compare two decimals, what we need to do is start comparing the tenths with the tenths and then move on to the hundredths with the hundredths, and we go from there. So it's pretty simple to do. Let's compare these guys right here. Okay, well, first of all, 0 and 0. We move on to the tenths position, 5 and 5. So far they look equal, but once we get to the hundredths position, we have an 8 and we have a 7, so it's crystal clear. It doesn't matter what happens at the end. Right here on the hundredths position, 8 is bigger than 7. So who cares if there's a 12 or a 1 and a 2? Who cares if there's a 9 and a 9? The 8 is bigger than the 7, so that tells you that it's a greater than symbol that belongs right there. Once again, you start by comparing, okay, that's a 0, that's a 0. I need to check the next position. On my tenths position, 5 and 5, they're equal so far. Your next position, 8 and 7. There you go. You're comparing the 8 with the 7, and it's obvious that 8 is greater than 7. It wants to eat the greater value. Let's move on to the next one. On this next one, you might be thinking, well, this 9 is greater than this 0, but that doesn't matter, because if you go to the ones position, right, the ones over here, 2 is not greater than 3. So just right there, you don't even have to compare the rest. When you start comparing 2 and 3, 3 is definitely greater than 2, so it stops right there. You put the inequality, you're done. Let's look at this next one. Comparing 0 and 0, so we have to go to the right side of the decimal, to the tenths position. 7 and 7, exactly the same. Moving on to the hundredths. 1 and 1, so they're still exactly the same. Moving on to the thousandths. 5 and 5, still the same. Then you go to the 10,000ths position, and that's 6 and 3. Now finally we get to comparing this 6 and this 3, so we know that it's greater than, has to open up to the 6. So once again, you go through from left to right, kind of like reading a sentence. 0 and 0 doesn't help you, got to move on. 7, 7, same thing, it's still equal. 1 compared to 1 is still equal. 5 compared to 5 is still equal. But once you get to this 6 and this 3, then you could give the inequality that belongs there. Last one, again, starting with 0 and 0. Okay, so 0 compared with 0, that doesn't help us. 0 and 0 are equal. Moving on to the tenths position, 5 and 4. And that's all you need to do, because right here you could compare the 5 with the 4, and you know that the 5's bigger. Okay, who cares if it has a 9, an 8, and a 9? That doesn't matter. When you get to the tenths position, you automatically see that 5 is greater than 4. Put that inequality there, and you're done. So that's how we compare decimals. And again, it's important to know the position of the digits here: tenths position, hundredths, thousandths. That's really going to come in handy when we convert decimals to fractions. So let's talk about converting decimals to fractions. And it's this simple. Whenever you see your decimal, go to the position that the last digit's in, and this would be the thousandths position. So if I wanted to convert this to a fraction, I would simply put it as 5/27 over the position that the last digit's in, thousandths. So I would put it over 1,000. As a matter of fact, the way you would read this decimal is 527 thousandths. And the way you would read this fraction, same thing, 527 thousandths, okay, over 1,000. So anyway, it's as simple as that, guys. Another way of, another little trick trick that might help you is just simply count how many positions there are. There's 1, 2, 3, and that'll be how many zeros you have. 1, 2, 3. Okay, so let's practice that. We have 0.3, and the 3 is in the tenths position, so you would just go 3 over 10. Or you could say, well, how many digits are on the right side of the decimal? There's 1, which means that you're going to have 1 0 after the 1. So you would read this decimal as 3/10. You would read this fraction as 3/10. Let's move on. This one, if you wanted to read it correctly, it would be 123 thousandths. Why is that? Because that's the thousandths position. Again, we have the tenths. We also have the hundredths. And of course, we have the thousandths. So we simply put the 1, 2, 3 over 1,000. And of course, you're supposed to try to reduce on all of these. I'm not sure if, yeah, we haven't been able to reduce yet. On this one, we will. Let's put that as a fraction. So as a fraction, that would be 80 over, and again, this is the tenths position, this is the hundredths position. So that'd be 80 over 100. And there's an easier way of doing this. I'll show you right now. Anyhow, when you do have the fraction 80 over 100, you could simply cancel out zeros. That'll be 8 over 10. And you could reduce 8 over 10 by 2 on top and bottom, and you'll have 4 over 5. That'll be your final reduced fraction that represents 0.80. But what I do want to mention is, if you ever have numbers with zeros as a decimal to the far right, like let's say I had, how about the number 3? Compared with 3.0. Is there a difference between 3 and 3.0? No. Okay. Or is there a difference between 3 and 3.000? No, it's the same exact thing. It's just 3, right? So if you do ever have numbers that with zeros to the right, on the right side of the decimal, you could just scratch those out because they're not necessary. Now, if you had a 5, then you wouldn't be able to scratch them out. But I mean, we don't have a 5, so if you have the zeros there, you could just scratch them out. So let's go back to the original problem. It says 0.80. That 0 at the end is unnecessary. You could scratch it out, and you could just rewrite this as a fraction. Now this is in the tenths position, which means that this fraction is 8/10. 8 over 10. And 8 over 10 reduces down to 4 over 5. Let's move on to our final topic on this lesson, comparing fractions. So there are different ways of comparing fractions. One way is to visualize, and let's talk about that, visualizing. Right here I have the fraction 3/4, and I want to compare it to 6/10. In order to do that, we need to understand the fraction. Now the denominator, the bottom number, tells you how many equal pieces to divide the whole into. So I have a 4 here. That means that I need to divide it into 4 equal pieces, and that's what I did already. 1, 2, 3, 4. Okay. So if this would have been a 5, I'd have to chop it up into 5 pieces. If it were 10, like over here, 10, I had to chop it up into 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the bottom number, the divisor, the denominator, tells you how many equal pieces to divide the whole into. Now the number on top, the numerator, that tells you how many pieces we actually want to consider out of the 4. So I'm talking about 3 out of 4. 3 out of 4 would be shading in 1, 2, 3 out of the 4. So if this were a tank of gas, if it were 3/4 filled, it would be up to here, 3/4. Okay. Now let's compare 3/4 with 6/10. So we already said that the bottom number tells you how many pieces to chop it up into. We already did that, 10 pieces. I need to shade in 6 of those. So when I shade in 6, we have 1, 2, 3, 4, 5. 5 out of 10 is halfway. 6 is a little bit more than halfway. However, as you can see, it's not as big as the 3/4. Here's 6/10. I mean, technically you could reduce 6/10 to 3/5 if you wanted to, but the bottom line is we have compared the fraction 3/4 with 6/10, and it's crystal clear that 3/4 is bigger than 6/10. Okay. Now, you might be thinking, man, this drawing business, it's not going to work out for me. Okay, so I'll be honest with you, comparing fractions visually is not the best method. So let's look at a different method. Number 2, get a common denominator and compare the numerators. That's awesome, getting a common denominator and comparing the numerators. So let's go back to this fraction right here, 3/4 and 6/10. So when we look at 3/4 and 6/10, we can't compare them yet because the denominators are different. If we could change both of these denominators to become the same denominator, then we could look at the number up here and the number up there and just decide which one's bigger. So the way I would do it is to look at your biggest one and see if you could convert the little one to that one. In other words, 4 times 1 is 4, 4 times 2 is 4 times 2, 10? No, it doesn't work. So 10 is not going to be the common denominator. Okay. A common denominator could be 40, but it would be a better idea to get the least common denominator. So once again, 4 times 2 is 8, not 10, so that didn't work. If I take 10 and multiply it by 2, that would give me 20. Now I need to think, could I change 4 to become 20? Absolutely, 4 times 5 is 20. So again, go with your biggest denominator and see if you could convert the smaller one to it, and if not, multiply it by 2 and then see if you could convert it to it. So right here we said the common denominator is 20. So I need to change both the 4 to become 20 and also the 10 to become 20. So 4 times 5 is 20, which means 3 times 5 is 15. Now that fraction 15/20, it's the same thing as 3/4. All I did was make it look different. Over here I need to change the 10 to become a 20, and I'm going to multiply by 2. And I'm also going to multiply the top by 2, and I'll get 12 over 20. Now that I have a common denominator, I could clearly see that 15 is bigger than 12. Once again, once I have that common denominator, whether it's 20 or 15 or whatever that denominator is, as long as they're the same, I'll be able to look at the numerators and see which one's bigger. Just compare numerators. So right off the bat right here, I know that 15 is greater than 12. So I know that the original 3/4 is greater than 6/10. So this is a second method of comparing fractions. I really like this method, and especially because you get practice on finding your LCD, your lowest common denominator. Let's practice a little more with that, getting that common denominator on both fractions. So right here, 2/5 and 3/10. Let's look at the biggest denominator, and the biggest denominator is 10. Could I convert the smaller one to become the bigger one? Absolutely. Okay, so we are going to use the denominator 10. So I need to change the 5 to become a 10, and the 10's already a 10. Okay, how could I change 5 to become 10? I multiply by 2. I multiply by 2. So I end up with 4 over 10. Now, the other one, I didn't do anything to that 10. I mean, if I wanted to write something, I could put times 1. Still going to be 3/10. But now that I have the common denominator 10, I could compare the numerator 4 with the numerator 3, which means 4 is bigger, so it has to open up to the 4. So I know comparing the 2/5 to the 3/10, 2/5 is bigger. If you try to do 2/5 and 3/10 visually by like drawing these rectangles and chopping them up, it's still going to be rough. It's going to be hard to do. So I really recommend finding a common denominator and comparing the numerators. This one's pretty easy as well. I could change the smaller denominator here to become the bigger denominator here by simply multiplying by 5. So if I go times 5 here, times 5 there, I'll have 5 over 15. And now I could actually compare that to the 4 over 15. And of course the answer is the less than symbol. It has to open up to the 5 because 5 is bigger than 4. Again, once you change either one or both to become that same denominator, then you could compare the numerator with the numerator, and 5 is greater than 4, so it has to open up to the 5. Now, that was the second method, and there's a third method. Use a calculator to divide, then compare decimals. So if you wanted to use a third method, well, first of all, you need a calculator. Right here, this fraction 3 over 4, it's actually a division problem. It's 3 divided by 4. This fraction 6 over 10, it's actually a division problem, 6 divided by 10. So if I take a calculator, and if I were to actually type in 3 divided by 4, it'll show up like that. And if I hit equal, it'll give me the decimal 0.75. So I'm able to come up with the decimal. 3/4 is really 0.75. And now let's do the same thing, but let's compare that with the division problem 6 divided by 10. And if I type in 6 divided by 10, hit equal, it'll come out like this, 6 over 10, that's 0.6. So let me actually rewrite the 6 over 10 as 0.6. And now we could compare the 3/4 as a decimal with the 6/10 as a decimal. And once again, you start with, okay, 0 and 0. I need to move on to the 10ths position. 7 and 6. Which one's bigger? Hey, the 7 is bigger than the 6, so I know it has to be a greater than symbol right there. And that's how we know, or how we could verify that the greater than symbol belongs right there between the 3/4 and the 6/10, opening up to the 3/4. So you could do that with any of these. Again, this is the third method I'm talking about here. To take your fraction, let's do this one. Let's compare 4 divided by 15. So if on the calculator I type in 4 divided by, and then 1, 5, and then hit equal, I will get the decimal. Let me write it down here. 0.266, and the 6 continues. Okay. Let me look at the 1/3. Let me do 1 divided by 3. So we go 1 divided by 3 on a calculator. We will get 0.333, and it continues forever. 0.333, and it continues forever. So let's compare the left decimal number with the right decimal number. And we're going to, of course, move through from left to right. 0 compared to 0 doesn't help us. When we get to the 10ths position, 2 is less than 3. 2 is less than 3. That means it has to open up to the 3, which means that when I compare the 4/15 with the 1/3, 1/3 is the bigger value, has to open up to the 1/3. I hope this helps. Good luck.